on the first part of it, what an arithmetic sequence is, it's super easy. You basically add or subtract the same amount between the terms. And then tomorrow, we'll get into the very exciting B part of the lesson where you add the terms together. Good stuff. Okay, so a couple things, of course, as far as notation. You know, we always start with 1 for the first term unless they tell you 0 or something else specific. So you're going to have your terms, of course, written out. And what is kind of nice about today is if it's arithmetic, you are adding or subtracting the same amount every time. They increase by 2, they decrease by 5, so on and so forth. Now, vocabulary, however much they're increasing or decreasing by, that is called your common difference. So if every time you're adding 3 between the terms, your common difference is 3. So take a look at this. Decide whether or not it's arithmetic. Of course, if it is, what's the common difference? So the question you're asking, are you adding or subtracting the same amount every single time between the terms? What's your answer to A? Yes, it is arithmetic. How much are you adding or subtracting? 2. We're subtracting 2, or they're going down by 2. So I'm going to say my common difference is -2. This is as exciting as it gets today, my friends. Okay, 1/3, 2/3, 4/3, 8/3, 16/3. Are you adding or subtracting the same amount between them? No, because, and I just kind of test it. From 1/3 to 2/3, I would have to add a third. That is not the consistent pattern between the terms. And of course, if it's not arithmetic, there's no difference. Okay, C. Are you adding or subtracting the same amount? I see some not sures. Sometimes I have kids say, yeah, they're going up by 1. And I'm like, are they? So think about what these values really are. 1 cubed, 2 cubed, 3 cubed, 4 cubed. Now look at them. Are they increasing? Are they increasing by the same amount each time? Obviously. So that's the only tricky part of this is sometimes they might give the values to you in a different form. Just think about if you simplify it, what those values would be. All right, we've done this a million times. Write the first 5 terms, decide if it's arithmetic. If it is, give the difference. Okay, so a throwback to the first section. Now, as always, probably I'm going to have way more work than you are for this. To get our first term, we're going to put 1 in for n. So I'm going to do 150 minus 7, really. Now, you probably are skipping that middle amount of work and just putting the 143, which is totally fine, okay? Then we're going to do 150 minus 14, 7 times 2. What's 150 minus 14?
136.
Got it. All right, then we're going to do 150 minus 21, really, 7 times 3. 150 minus 21. And again, if you just have the answers that have circles because you're just punching them in your calculator, totally fine. 150 minus 7 times 4, or 28. What's 150 minus 28? 122. And of course, our final term, 150 minus 7 times 5, or 150 minus 35. What's 150 minus 35? Yeah, perfect. All right, next question it asks you, is it arithmetic? Are you adding or subtracting the same amount each time? Yes. Clearly, the terms are decreasing, so we're subtracting, so our difference will be a negative. How much are you subtracting each time? 7. This is as tough as it is today. I maybe have one tricky problem for you. That's it today, my friends. Okay, same thing, first 5 terms. And remember, we always start with 1, of course, unless it indicates differently. Always assume you start with 1. All right, let's do some mental math. If I put 1 in here, I'm going to have 2 to the 0, anything to the 0 power. Okay, 2 minus 1, 2 to the first. Then we're going to put a 3 in. 3 minus 1, 2. 2 squared. You're probably done already. 4 minus 1, 2 cubed. What's 2 cubed? 8. And our last term, we're going to put a 5 in. 5 minus 1, 4. What's 2 to the 4th? Okay, look at the terms. Are you adding or subtracting the same amount every time?
No.
Clearly not. Now, different question for you. Before you flip it, different question. There is a pattern between these terms. What is the pattern? We go from 1 to 2, 2 to 4, 4 to 8, 8 to 16. What's the pattern? They're doubling. You're multiplying by 2. This, just think about our next section, is a glimpse into 8-3. This is what we call a geometric sequence. If you are multiplying by the same amount, it's geometric. We'll see some more of that coming at us. But today our focus is, of course, arithmetic. Now, the nice thing about these, no more do I give you that list of terms and be like, hey, randomly make me the formula, pulling it out of thin air. You've got a nice formula to use, my friends. And this is the first formula on your formula sheet, which I'm going to give you today, obviously. Now, first term, of course, is A1. That's what you're going to have to fill in. And obviously, D is our common difference. So, find the formula, AN, for the arithmetic sequence. They gave you everything we need. So the first term, n minus 1. Now, because the difference is negative 8, I'm going to put it in parentheses. I don't want it to look like minus 8. That's why. Now, good mathematicians that we are, we're going to distribute and simplify because there are some like terms that we can combine. Negative 8 times n, negative 8, negative 1. So I'm going to, of course, add or combine the 100 and the 8 together. This is just me. I like the variable first. You don't have to have it first. This is how I like it. Now, you're going to see they're going to be asking us a lot today and on the homework to come up with the formula. The reason why, once you have the formula, I can get you any term you ask me. You want the, 87th term. I throw an 87 in there for n, and I can calculate it for you. All right, this is just as easy, just maybe not as obvious. Okay, what's the first term? 4. Now, you're going to have to do a little mental math here. What's the difference? How much are they decreasing by? If it helps, think of that as a mixed number. That's 1.5. From 4 to 1.5. 1.5 to negative 1. How much are you decreasing by? 2.5. Good, Ethan. As always, our love of fractions in here is strong. Okay, so we have everything. Let's write our formula. The first term, I'm just going to steal it off the sequence up there, 4, n minus 1. Same spiel, since our difference is negative, I'm going to put it in parentheses so it doesn't look like subtraction. Distribute, combine the like terms, do all the stuff. And again, what's important, why we keep doing this formula, once you have that, if I ask you for any term, you just plug that number in and you can calculate it. Easy enough. Yeah, this is as wild as it gets. Okay. Find the common difference. The first 6 terms, the nth term, okay, we got a lot to do, but not hard stuff. We just have a lot to answer. I'm going to start with the easy, the difference. Well, don't stress this. How much are they decreasing by? 6. Got it? First 6 terms. Well, I'm not even going to rewrite them because they gave you the first 4. I'm just going to tack on the next 2 behind it. So if we're decreasing by 6, what's negative 5 minus 6? Negative 11. What's negative 11 minus 6? And I'm just going to circle them. Make it easy. I'm not going to rewrite them since I gave you 4. Okay, nth term. So that is, of course, the formula that we just did on the previous 2. So first term, which I'm just going to steal over there off the sequence, which is 13, n minus 1, and the difference. Now, some of you can probably distribute and combine the like terms all in one step and go right to your answer. Honestly, that's usually what I do because I'm like, okay, that's going to be negative 6n. And you know I like the variable first. And then this is going to be a plus 6. So combine 13 plus 6. So you can kind of skip some of that little algebra if you can do that in your head. Now, again, I've been saying it. Here's why. Once you have the formula, I can get you any term you want. Well, Lord knows I'm not writing out the sequence to the 300th term. Gross. We're just going to put a 300 in here and punch this in our calculator. So we're going to do negative 6 times 300 plus 19. And again, I wouldn't even show work for that. I would just straight type that into your calculator. What is your 300th term? Negative 1781. Perfect, Ethan. Mental math, I like it. Any questions on that guy? And this was just a time-consuming one because they asked us for so much stuff. Not that it was hard, but we just had to do a lot of things. All right, next up, let's take a look at what we have. Write the first 5 terms of the sequence, and we'll talk about your calculator here in a minute. I'm going to do the calculator part at the end. First 5 terms. Well, okay, they give you the first one. Okay. A2. Now, common difference is -2. Can't we just mental math it quick down the line? What's 5 minus 2? 3 minus 2. 1 minus 2. I sound like a broken record. -1 minus 2. And we're done. Okay, that was super exciting. Now, next one's going to take a little more work. Because, 1, they have a gap, meaning you go from the 6th term to the 11th term. And we don't know the common difference. So we got to do a little bit of investigating here. Not hard work, but we got to kind of think our way through this problem. So first thing I'm thinking about, okay, because I'm working on the difference. Clearly it's decreasing. If we're going to go from -38 down to -73. My question to you is, how much is it decreasing by? I hear you typing in your calculators. I would too. So figure that out. How much is it from -38 to -73? Who's got it? From -38 to -73. Hannah.
35.
So we are going down 35. Now, easy question. How did we calculate that? You did what? Add, subtract, multiply by? You subtracted it, okay? So that's the first thing. From -38 minus 35 gets you to -73. Now, we want the difference between each individual term, not from the 6th down to the 11th. So again, some math here. From 6th to the 11th term, how many terms is that?
5.
So I'm going to equally divide that -35 by 5. And that's going to be my difference. You can mental math that. So each individual term is now going down by 7, which was the first thing we needed. Now, next up, I'm like, oh man, we need the first 5 terms, remember. Well, there's multiple ways to do this problem, and I'm going to show you both. We'll see it happen on both. But I'm like, wait a minute. I think I can be smart here and kind of count backwards. Meaning, they give me, let me write it over here so I'm not getting out of it. They give you the 6th term, and we want the first 5 terms. So I want the green ones. Now, because they give you the 6th, I think I can just mental math the others. But down the line, they should each be decreasing by 7. I'm going backwards. So I'm not going to subtract 7. I'm going to do what? Add. So add 7 to this. What's -38 plus 7? Add 7. Negative what? Yep. Add 7. Add 7. Add 7. And now I just check down the line, they are decreasing by 7. But we're after those. Now the question is, what if I'm a real jerk to you and I give you, like the first term I give you is like, I don't know, the 23rd term. Hey, flip the page, let's talk about it. Our spicy problem of the day, everybody. So, 11th term's 52. 19th term's 92. Ooh, okay. And we need the 1000th term. Okay. Now, first, a lot of words here, people, a lot of words. I'm going to first just rewrite these in terms, in numbers, in mathematical notation, just because that's how I like it, okay? And then, of course, we've got our 19th as the 92nd. Now, first off, just like the previous problem, on these sequences, the most important aspect you need is that difference. So I'm like, okay, let's do the difference. From 52 to 92. You're clearly going up by how much? 40. Now, that's the difference from those 2 terms. I want the difference between each individual term. Well, from 11 to 19, how many terms is that? 8. So what is going to be the difference between each individual term? 5, because we did 40 divided by 8. So a little calculating there, not hard calculating, but you know, we gotta first figure that out. Now I'm like, oh boy, they want the 1,000th term. So I want to come up with that formula, meaning, just to flash it back, of course it's on your notes here, I want to come up with the AN formula so I can just put 1,000 in it and punch it in my calculator. I'm not writing out 1,000 terms, let's get serious. Okay, so first I'm going to jot the formula so it's in front of us. Now, I'm looking at this formula and I'm like, okay, what do I know on the formula? I know the difference. We just figured out the difference was 5. I'm going to have to figure out the first term. Clearly they didn't give it to me. I mean, you got the 11th. I could try to count it down. That seems like a lot of work. We're just going to find it here. Here's where it's going to get fun. Now, you can pick that 52 or the 92. Doesn't matter which term you pick to pop in here. Generally, you know my motto, I pick smaller numbers, just less likely chance to make an error. So I'm going to think about this term. So now my 11th term is 52. So n represents the term, and it should equal 52. So that's kind of the tricky part. N, remember, represents what term, and I know what it should equal. I could have put 19 and 92 in here. I just chose to use smaller numbers. Now I can go through and I can figure out what A1 is for you. So I'm going to do some math here, of course. So 11 minus 1, 10 times 5. Mental math, what's the first term? 2. So if it just wanted the first 5 terms, you got this, keep adding 5, keep adding 5, keep adding 5, keep adding 5. But sick, they want the 1,000th term. I'm not writing out 1,000 terms. So I'm thinking about my formula. We've got the first term, n minus 1. We already knew the difference from like 5 minutes ago. So same spiel. I'm going to distribute, combine the like terms, make it look nice. So of course I'm going to have my 5n minus 5. So I'm going to combine 2 minus 5. Once you have that formula, I can get you anything you want. Well, this one's crazy. It wants the 1,000. So let's throw 1,000 in here. I don't even think we need a calculator. What's 5 times 1,000? 5,000. I'm running out of room. I'm going to put the minus 3 underneath. What's 5,000 minus 3? That's why this is a spicy one, okay? Now, there's not a lot of those, and it's really not that hard, but you really got to think your way through it. Clearly the difference, I have total faith in you getting the difference. I know you can do it. The tricky part, or what you have to catch to get the first term, is I just plugged in one of the terms, and you could have done either. The 11th term is 52, or I could have put the 19th term is 92. You will get the same thing. So that's the tricky part, is to plug that term in. Hey, that was a good one. I liked that one. Okay, write the first 5. I feel like we've been writing the first 5 terms forever here. Write the first 5 terms, figure out the difference, blah, blah, blah. Okay, they give you the 6, 2, 4, 5. Now, again, is, you know, practicing our recursively defined sequence. K plus 1, you got to look at those subscripts. We know K plus 1 is higher, so to get your next term, it's the last one plus 5. All right, we can do it. So last term plus 5. What's 6 plus 5? 11. 11 plus 5. And you probably don't have to write what I'm writing in the middle. That's fine. 16 plus 5. And 21 plus 5. Got it. Now here's a very riveting question. What's the common difference? 5. We added 5. Okay? And it wants the nth term of the sequence, the formula. Remember, we're asking you to write the formula, because once you have that, I can get you any term I want. So first term, 6, n minus 1. You told me the difference was 5. Same spiel. I'm going to distribute, combine the like terms, and circle it up. So I'm going to have 5 times n. Now, some of you can distribute and combine right now, because you're going to have minus 5 here. So it's 6 minus 5. And of course, if I ask you for the 1,000th term, you could very easily find that by just putting 1,000 in there, okay? Any questions on that guy? Hey, let's review for finals, shall we? Nobody's excited? Where's the enthusiasm, kids? A good word problem? This is gonna be good. A loading dock ramp is 18 feet long. Okay, let me draw that. So ramp, slanted. Angle 17.8 horizontal. Horizontal. Due to a new design, a longer ramp is going to be used, so the angle is reduced to 8 degrees, and the ramp still reaches 5.5 feet up the wall. So which is the wall? The bottom horizontal or the vertical? So let's label this. And I want to figure out how much further from the dock will the foot of the ramp be. So I need to figure out this. Now we're going to talk about how you can find that in a minute. But here we go. We're doing a new design, a longer ramp. I don't know that it's 18 feet, it's longer. I don't know what it is, whatever, okay. 8-degree angle, who teeny tiny, not drawn to scale. I know the ramp's longer, whatever. It still is the 5.5 feet up the wall. How much further out from the dock? So I need to still find this horizontal side. And then I just have to figure out, once I get that answer in this one, how much further, how much more did you have to add for their second answer? Well, let's get these answers first. A couple ways you can get x here, I don't care. You could do Pythagorean theorem, because you know 2 sides of the right triangle to get the third one. You could use SOHCAHTOA too. I decided to use SOHCAHTOA, I thought that seemed quicker. I did tangent, opposite, adjacent. So I did tan of 17.8, opposite, adjacent. And like I said, you could do Pythagorean theorem. I don't care, you'll get the same thing. I times by x to clear out the fraction. I know you can punch this in. I divided tan of that. Make sure your mode's in degrees, of course. And I got 17.14 feet. Now, I did the same thing here. I did tangent, but I switched it to 8 degrees. Same thing. I multiplied by x to clear the fraction. Made sure my mode was in degrees, and I divided that off. And for this one, I got 39.1. And of course, we're in feet. So final answer. It asks how much further out from the dock will that put the foot of the ramp? So we're going to go from 17.1 to 39.1. How much further out did you have to put it? 22. You're just going to subtract them. Any questions on that? Hey, for fun, look at the very last page of your note packet. Should we do a couple of these too while we're in it? Yeah. Okay, let's do this first. Let's do the first couple. Why not? We've got some time. Okay, factor the following. And you'll see, like, obviously I have a lot of chapter 5 stuff on here because it's been since January since we've done this, okay? And that's the first chapter on the final. All right, factor the following. This is easy. What's the first thing you look for when every factor? Starts with a G. Our greatest common factor, what's our greatest common factor? So let's just factor that out and we're done. Piece of cake, right? Piece of cake. Okay, let's do this guy. Find all solutions. Now, we're solving an equation. You should always isolate the variable, just like algebra 1, to start it. So we'll get cos to x alone. I'm going to add 2 root 3 over and divide off the 4. All right, 2 over 4, let's reduce it to a half, of course. Now, you're solving for x, which is the angles, plural. What angles have a cosine value of root 3 over 2? And they want the answers if you look at the directions and radians, I mean, whatever. So, what is that fun-filled little saying we use to help us figure out where to draw the triangles? Got it. And remember, this is telling you where the trig functions are positive. Everything's positive in 1, sine in 2, so on and so forth. Cos, of course, positive in 1, and down here in 4. I'm going to start in 1. Now, of course, cosine represents the adjacent and the hypotenuse from this angle, which I'm trying to figure out. Adjacent, hypotenuse. For the thrill of knowledge, what would be the third side?
1.
And more importantly, what's the angle across from 1? 30. We're on the 30, 60, 90, that's the 30. So there's my first answer. And just because of the directions, it asks for radians. Okay, whatever. What's 30 in radians? Pi over, got it. Now, I don't get crazy and like, oh, I'm going to redo Grail's triangle. I care about the 30. I mean, you can relabel if you want. But of course, my answer is not 30. We are in quadrant 4. You are 30 short of a full circle. So what's your second answer in degrees? Which then in radians, is it coming back to you? Coming back? Okay, let's do one more and then I'm done with this. Just because, isn't this similar? Let's do this one. So of course I'm going to solve for tan of x. Let's subtract root 3 over. Oh boy. Now, you know I like it fraction style. So I'm just going to put it, I know you know it's over 1. I'm just going to put over 1, so I have opposite adjacent, you know. Same spiel, we got to figure out where to draw. We are after the angles in radians. Again, thinking all students take calculus. But we got to be careful here because your tan is negative. So that gets rid of 1 because everything's positive 1, and it gets rid of 3 because tan's positive in 3. So I'm down to 2 and 4. I'm going to start in 2. Okay, TOA, opposite, adjacent. Now I put the negative here on the 1 just because of the location. I don't even care what the hypotenuse is. You know the hypotenuse. I care about what's this angle across from root 3. 60. Now my answer is not 60. 60 would be in quadrant 1. You have to measure from 0 over. You're 60 short of a half circle. So what is it in degrees first? And then radians. Got it. And then of course for my second answer here in 4, I don't get crazy and redo the size. I already did the work. I got the work. I know the 60, but I got to measure from 0. What's 60 short of a full circle? 300. And then in radians, got it. So easy. It's all coming back to us, right?
Yes.
Go, man.